March 1898. A fortified room deep within the Puteaux arsenal outside Paris. Behind locked doors and armed guards, French artillery officers gathered around a gun that would change warfare forever. They called it simply the 75, the Canon de 75 Modèle 1897. What they were looking at seemed ordinary enough, a field gun with an 8-foot barrel mounted on wooden wheels. But this weapon contained a secret that France had guarded for nearly a decade. A secret so valuable that when it was finally revealed, one American officer would remark that the French would sooner lose the war than lose the secret of the 75. The story of the French 75 begins not with triumph, but with humiliation. The Franco-Prussian War of 1870 had ended in disaster for France. Prussian artillery had systematically destroyed French positions. Paris had fallen. The new German Empire was proclaimed in the Hall of Mirrors at Versailles, rubbing salt into French wounds. The French military establishment understood the message. Artillery had decided the war, and French artillery had been found wanting. In the decades that followed, France rebuilt its military with artillery as the cornerstone. But by 1890, a new problem emerged. Every army in Europe was developing better field guns, and France risked falling behind again. General Charles Mathieu, director of artillery at the French Ministry of War, received troubling intelligence that year. The Germans were experimenting with a revolutionary recoil system invented by Konrad Hausner, an engineer at the Ingolstadt arsenal. If the Germans perfected it first, France would face the same artillery disadvantage that had cost them so dearly in 1870. Mathieu acted decisively. He turned to Lieutenant Colonel Joseph Albert Duport, director of the Atelier de Construction de Puteaux, the state arsenal. The instructions were simple but urgent. Develop a gun with a long recoil system that could outperform anything the Germans might produce, and do it in absolute secrecy. What followed was one of the most audacious covert weapons programs in military history. Duport received no official authorization, no contracts were signed, no records appeared in official channels. Mathieu diverted 300 million francs from a fund normally used to purchase property around Paris. All correspondence, including Duport's weekly progress reports, was classified. The French were building their next-generation field gun completely off the books. The challenge Duport faced was fundamental to artillery design. When a cannon fires, the explosion that propels the shell forward also drives the gun backward with tremendous force. Throughout history, this recoil had plagued gunners. Heavy fortress guns were mounted on massive carriages that could absorb the shock. But field guns needed to be mobile, light enough for horses to move quickly. This meant every time a field gun fired, it jumped backwards several feet. The crew had to reposition it, re-aim it, and only then could they fire again. The best gun crews in the world could manage perhaps 2 aimed shots per minute. Duport's solution lay in fluid dynamics and compressed gas. Beneath the gun barrel, he designed a cradle holding 2 hydraulic cylinders. The upper cylinder contained hydraulic fluid. The lower cylinder held compressed gas, separated from the fluid by a floating piston. When the gun fired, the recoiling barrel drove the fluid through a port into the lower cylinder, compressing the gas. The compressed gas then pushed back against the piston, forcing the fluid back into the upper cylinder and returning the barrel to its original position. The entire cycle took about 2 seconds. The gun carriage never moved. The wheels stayed planted. The trail spade stayed buried. Only the barrel recoiled and returned. This meant the crew never had to re-aim between shots. But solving the hydraulic problem took years. Early prototypes leaked. The seals failed. Fluid escaped under the tremendous pressures generated by recoil. Krupp had actually tested Hausner's system and rejected it for exactly this reason. They couldn't solve the leakage problem. In December 1894, Duport himself left the project after being passed over for promotion. He resigned and joined a private armaments firm. The work continued under 2 young military engineers from École Polytechnique, Captains Étienne Sainte-Claire de Ville and Émile Remello. Their breakthrough came in 1896. They developed improved silver alloy rings for the floating piston that created a leak-proof seal even under extreme pressure. They called their system Freen 2, break number 2. It worked flawlessly. The complete weapon that emerged integrated several cutting-edge technologies. The 75mm caliber provided an optimal balance between shell weight and gun mobility. The barrel was rifled to spin the projectile for accuracy. But the real innovations went beyond the recoil system. The breech mechanism was a Nordenfelt rotating eccentric screw design, licensed from Swedish inventor Thorsten Nordenfelt. A single quarter turn of the breech handle opened the chamber. Another quarter turn closed and locked it. Simple, fast, reliable. The ammunition was fixed. The shell and propellant charge came as a single unit, like an enormous rifle cartridge. This eliminated the separate loading steps that slowed traditional artillery. A well-trained crew could load, fire and reload in 2 seconds. The sight was revolutionary. Unlike earlier guns where the sight was attached to the barrel, the 75's sight mounted independently on the carriage. This meant the sight remained on target even as the barrel recoiled and returned. A collimator telescope enabled precise direct-fire aiming. For the first time, gunners could actually see their target and adjust fire in real time. The gun shield was 7 pieces of nickel steel that protected the crew from shrapnel and small arms fire. A seat mounted on the trail allowed the gunner to sit while operating the weapon, something impossible with guns that jumped backward when fired. When all these elements came together, the result was breathtaking. A trained crew of 6 men could fire 15 rounds per minute sustained. In short bursts, with a highly skilled crew, the rate reached 30 rounds per minute. Previous field guns fired 2 rounds per minute. The French 75 had increased artillery firepower by a factor of 10. The gun itself weighed 2,650 pounds with its carriage, light enough for a 6-horse team to move at a gallop. The barrel was 8 feet 10 inches long, giving it a range of 9,300 yards for high explosive shells and 7,400 yards for shrapnel. This was significantly farther than contemporary German field guns. The 75 fired 2 main types of ammunition. Shrapnel shells contained lead balls packed around a small bursting charge with a time delay fuse. The shell would explode above and in front of enemy troops, showering them with hundreds of metal balls. This was the primary anti-personnel round, designed to slaughter infantry advancing in the open. High explosive shells used melanite, a powerful explosive based on picric acid that the French had developed. These shells were designed to impact detonate, blasting trenches, destroying equipment, and killing anyone nearby. The shells weighed about 12 pounds and left the muzzle at 1,600 feet per second. On March 28, 1898, the Canon de 75 Model 1897 entered French service. The hydro-pneumatic recoil system remained classified at the highest level. Foreign military observers were allowed to see the gun but not to examine the recoil mechanism. Guards stood watch over every 75 in service. The French claimed the mechanism was too delicate to be opened for inspection. This secrecy would be maintained for nearly 2 decades. Production began immediately at French state arsenals. Puteaux, Bourges, Châtellerault and Saint-Étienne all manufactured components. The barrel and the complex recoil mechanism were considered too sensitive to be contracted to private firms. Only government arsenals with cleared workers could produce them. By August 1914, when World War I began, France had 4,000 Canon de 75 Model 1897 field guns in service. They were organised into 1,000 batteries of 4 guns each. This represented the entire backbone of French field artillery. The Germans also had about 4,000 field guns in 1914. Their main weapon was the 77mm Feldkanone 96, developed by Krupp. It was a capable gun, but it lacked the hydro-pneumatic recoil system. The German gun had to be re-aimed after each shot. Its maximum range was 5,500 metres, compared to the 75's 8,150 metres. Its rate of fire was perhaps 4 rounds per minute compared to the 75's 15. On paper, the French had a decisive artillery advantage, but wars aren't fought on paper. August 1914, the German army invaded Belgium and northern France with a massive right hook aimed at Paris. The French, executing their own plan, attacked into Alsace and Lorraine. In these opening battles of movement, the French 75 proved itself immediately. At the Battle of the Marne in September 1914, French artillery stopped the German advance just 30 miles from Paris. Batteries of 75s, positioned with clear fields of fire, unleashed devastating barrages on German infantry advancing across open ground. The rapid fire was unlike anything the Germans had experienced. One French civilian watching a battery in action near Mulhouse reported seeing 4 75s destroy an entire German artillery battery on a hill, killing most of the gun crews and all the horses in a matter of minutes. But the war of movement ended quickly. By November 1914, the front had stabilised into continuous trench lines stretching from the English Channel to Switzerland. And in trench warfare, the limitations of the 75 became apparent. The gun had been designed for direct fire against troops in the open. It had a relatively flat trajectory with an elevation range of only -11 to +18 degrees. This was perfect for shooting across open fields at visible targets, but trench warfare demanded high-angle indirect fire to drop shells into enemy trenches and rear areas. The 75 struggled in this role. Its shells, optimised for anti-personnel work, lacked the explosive power to destroy heavy fortifications. The Germans brought up heavy howitzers that could lob massive shells in high arcs, demolishing French positions. The French found themselves outgunned in the static artillery duels of trench warfare. The French artillery establishment scrambled to adapt. They developed new ammunition types. Impact-detonated high-explosive shells became standard. By 1918, the 75 was the primary delivery system for poison gas shells as chemical warfare escalated. They modified gun positions to allow for higher elevation angles. Most importantly, they produced massive quantities of ammunition. Over 200 million 75mm shells were manufactured during the war, mostly by private contractors working around the clock. The true test of the 75 came at Verdun. In late 1915, German Chief of Staff Erich von Falkenhayn chose Verdun for a massive offensive. The ancient fortress city held enormous symbolic value for France. Falkenhayn's strategy was one of attrition. He would attack Verdun not to capture it, but to force France to defend it. French reserves would be drawn into a killing zone where German artillery would bleed France white. On February 21, 1916, the German bombardment began. Over 500 heavy guns, including 13 massive 420mm siege mortars, hammered French positions. The Germans had stockpiled 2.5 million shells. The French defenders had only 6,400 rounds for their 75s. Falkenhayn had achieved complete artillery superiority, but the French responded with a logistical miracle. A single road led into Verdun from the south. French engineers converted this road into a conveyor belt of men and material. Trucks rolled forward loaded with ammunition and fresh troops, then returned with wounded and exhausted soldiers. Engineers maintained the road under constant bombardment, filling shell craters as fast as they appeared. French artillery poured into Verdun. By March, over 1,000 75s were in action around the fortress. By June, that number exceeded 1,000 guns in 250 batteries. The French established a rotation system. Batteries would fight for days or weeks, then rotate out for rest and refit while fresh batteries took their positions. This meant French artillery could maintain continuous fire. The 75s at Verdun fired day and night for 9 months. The sustained bombardment was unprecedented. From February 21 to September 30, 1916, French 75s alone fired over 16 million rounds. This represented nearly 70% of all shells fired by French artillery during the battle. The sheer volume of fire offset the 75's limitations. German infantry attacking across the moonscape of Verdun faced curtains of steel and high explosive. The rapid fire capability meant that a single battery of 4 75s could put 60 shells per minute into a target area. Nothing could survive in that maelstrom. One German soldier who survived an attack at Verdun described it as walking into a wall of iron. The French shells arrived in a continuous stream with no pause between impacts. Men simply disintegrated. Equipment vanished in explosions. The ground itself seemed to be dissolving. The psychological effect was devastating. German troops called the French artillery drumfire a continuous rolling thunder that never stopped. Men went mad under the bombardment. Some German units mutinied rather than advance into French artillery fire, but the price was terrible. French casualties at Verdun exceeded 377,000 men. German losses were 337,000. The battle lasted 302 days and achieved nothing strategically. Both armies were broken. Yet Verdun became a symbol of French determination, and the 75 became a symbol of French resistance. April 1917. The United States entered World War I utterly unprepared for modern warfare. The US Army numbered about 130,000 men. It had virtually no heavy equipment. American field artillery consisted primarily of obsolete 3-inch guns that lacked modern recoil systems. The Americans would need to equip millions of soldiers being raised for the American expeditionary forces. Buying weapons from the Allies was the only realistic option. For artillery, the choice was obvious. The French agreed to supply their American allies with the Canon de 75 Model 1897. The Americans called it simply the French 75, or the 75. General John J. Pershing, commanding the AEF, particularly appreciated the weapon. French training facilities were established to teach American artillerymen. The French finally revealed the secrets of the hydro-pneumatic recoil system to their American allies, though with some reluctance. The first American shot of World War I was fired on October 23, 1917, by Corporal Robert Brelet of Battery C 6th Field Artillery. He used a French 75 named Bridget. That gun is preserved today at the United States Army Ordnance Museum. Among the American officers commanding French 75s was Captain Harry S. Truman, future President of the United States. France supplied about 2,000 French 75s to the AEF. American factories, after struggling to master metric measurements and French specifications, eventually produced about 1,050 guns domestically under license. By the war's end, French 75s equipped the majority of American field artillery. The Americans took to the 75 immediately. Doughboys called it the saucy can, their attempt to pronounce 75. They found it accurate and reliable. American gun crews quickly became proficient. During the Saint-Mihiel offensive in September 1918, American 75s fired 1 million rounds in 4 hours. Half of the 3,000 guns used in the offensive were 75s, which fired 2/3 of all ammunition expended. By the war's end, American 75s had fired over 6 million rounds. One American battalion developed an unconventional tactic. They used single 75s firing at maximum rate, frequently changing position by towing the gun behind trucks. This mobility deceived the Germans into believing they faced multiple batteries. The high rate of fire from one gun sounded like 4 guns firing normally. The psychological effect on German troops was profound. November 11, 1918. The armistice ended World War I. By that date, over 17,500 French 75s had been produced, in addition to the 4,100 already in service when the war began. The gun had fired over 200 million rounds. It had become the defining artillery piece of the Western Front. French casualties in the war exceeded 1.3 million dead. But France had survived, and many credited the 75 with making survival possible. After the war, the Canon de 75 Model 1897 became one of the most widely distributed weapons in the world. Over 30 countries purchased or manufactured the gun under license. The United States, Poland, Romania, Belgium, Portugal, Greece, and many others equipped their armies with the 75. It had proven itself in combat and became the standard by which field artillery was judged. The interwar period saw modifications. The original wooden-spoked wheels were replaced with pneumatic rubber tyres for towing behind trucks rather than horses. The box-trail carriage was replaced with a split-trail design that allowed greater traverse and elevation. These modernised versions were designated the 75 Model 1897-33 in French service. Anti-aircraft versions had been developed during World War I, with the gun mounted on truck beds or specialised high-angle mounts. These evolved through the 1920s and 1930s into sophisticated anti-aircraft systems. Poland received substantial numbers of 75s between 1990s and 1920 to fight in the Polish-Soviet War. By 1939, Poland had 1,374 of these guns, making it by far the most numerous artillery piece in Polish service. They knew them as the 75mm Armata WZ 1897. The United States maintained large stocks of 75s through the lean years of the 1920s and 1930s. Budget constraints prevented development of new artillery. The Westervelt board recommended a new 75mm design, but it remained experimental. Meanwhile, thousands of 75s sat in storage or equipped the few active artillery units. By the 1930s, only artillery assigned to infantry and cavalry divisions remained horse-drawn. The rest were motorised, with 75s towed by trucks. September 1st, 1939. Germany invaded Poland, beginning World War II. Polish artillery, including hundreds of 75s, fought desperately against the overwhelming German assault. the Polish guns performed adequately but were overwhelmed by German combined arms tactics and air superiority. Hundreds of Polish 75s were captured intact by the Germans, May 10, 1940. Germany invaded France and the Low Countries. The French army still fielded about 4,500 Canon de 75 Model 1897 guns, now modernised with rubber tyres and improved carriages. But the nature of warfare had changed fundamentally since 1918. German armour and aircraft dominated. The static defensive mindset of French commanders proved disastrous against mobile warfare. The 75s fought throughout the Battle of France, but they were outmatched. The guns' relatively short range and low shell weight were liabilities against German tanks and motorised forces. German artillery had evolved, with guns specifically designed for mobile warfare. More critically, German combined arms tactics integrated armour, artillery and aircraft in ways French doctrine couldn't counter. On June 22, 1940, France surrendered. The Germans captured thousands of French 75er. This windfall, combined with the Polish guns captured in 1939, gave Germany one of the largest stocks of 75mm artillery in Europe. The Germans were nothing if not practical. They gave the captured guns the designation 7.5 cm FK97F, the F indicating French origin. Initially, these guns were issued to second-line units, coastal defence forces and occupation troops. But the German invasion of the Soviet Union in June 1941 changed everything. German forces encountered the Soviet T-34 medium tank, a revelation that shocked the Wehrmacht. The T-34's sloped armour defeated German anti-tank guns. Desperate for any weapon that could stop the T-34, German engineers looked at the captured French 75s. The guns had good muzzle velocity and fired a decent-sized projectile. Could they be converted to anti-tank use? The Germans developed a crash program. They mounted captured 75 barrels on the carriage of the 5 cm Pak 38 anti-tank gun. A muzzle brake was added to manage the increased recoil forces. German ammunition factories produced armour-piercing shells for the 75mm bore. Over 3,500 of these conversions were completed. The weapon was designated 7.5 cm Pak 9738. It wasn't ideal. The muzzle velocity was relatively low compared to dedicated German anti-tank guns, and penetration against heavy Soviet armour was marginal. But it was available in large numbers, and it was better than nothing. German anti-tank units used the Pair 9738 throughout 1942 and 1943 on the Eastern Front. Some remained in service until 1944. The gun that had been designed to kill infantry with shrapnel in 1897 was now killing tanks on the Russian steppes in 1942. The captured 75s also found use in the Atlantic Wall, Hitler's coastal defence system. Thousands of guns were mounted in concrete bunkers overlooking beaches from Norway to Spain. These positions would face Allied invasion forces in 1944. Meanwhile, Britain faced its own artillery crisis. The British Expeditionary Force had lost most of its equipment during the evacuation from Dunkirk in May 1940. Britain desperately needed field guns. In June 1940, the United States sold 895 French 75s to Britain, along with 1 million rounds of ammunition. For political reasons, the sale was conducted through US Steel Corporation, rather than directly from the US Army. The British designated them Ordnance Kure 75mm Mark I. These guns equipped field artillery and anti-tank units. Some had their wheels and carriage sections cut away to mount on pedestals for coastal defence. These modified guns remained in British service until declared obsolete in March 1945. The United States also found continued use for the 75 in World War II. Although newer artillery was being developed, large stocks of 75s remained available. In 1941, American engineers developed the M3 gun motor carriage, an emergency tank destroyer design. They mounted a 75mm gun on an M3 half-track chassis. This improvised vehicle served until dedicated tank destroyers could be fielded. The gun proved effective against early German and Japanese tanks. The US Army also used 75s in the Pacific Theatre. The 75mm gun was installed in early model M3 Lee medium tanks. These tanks saw action in North Africa and the Pacific in 1942 and 1943. The gun remained viable against Japanese armour throughout the war. American 75s also served in secondary theatres and training roles throughout the conflict. The Free French forces, fighting alongside the Allies after France's fall, continued to use 75s wherever they could be obtained. French units in North Africa employed them against German and Italian forces. After the liberation of France, French artillery was re-equipped by the Americans, but some 75s remained in service until war's end. Perhaps the gun's strangest World War II role came at the hands of Canada. In 1942, facing the threat of Japanese invasion of British Columbia, the Canadian Army assembled the No. 1 Armoured Train for coastal defence. 2 French 75s were mounted on the train, one at the front and one at the rear. The train patrolled the British Columbia coast through 1943, a rolling fortress armed with weapons designed in the 1890s to fight a war in 2025 that never came. By 1944, the 75 was clearly obsolete as a frontline field gun. Newer designs with longer range, heavier shells, and better armour-piercing capability had superseded it. But the gun remained in service because it was available in enormous numbers and it still worked. One final major action occurred at Dieppe in August 1942. German forces used captured French 75s in fortified positions to defend against the Allied raid. A battery of 75s firing at point-blank range contributed to the devastating losses suffered by Canadian troops during the disastrous operation. The Germans recognised the 75's value for defensive positions where rate of fire mattered more than range. By war's end in 1945, the Canon de 75 Model 1897 had served in both world wars across every major theatre. It had fought on the Western Front, the Eastern Front, in North Africa, the Pacific, and everywhere between. It had been used by France, the United States, Britain, Poland, Romania, Belgium, Greece, Portugal, and numerous other countries. It had been captured and used by Germany. It had served as a field gun, an anti-aircraft gun, an anti-tank gun, a coastal defence weapon, and a tank gun. It had fired over 200 million rounds in combat. No field gun in history had seen such widespread and varied service. After World War II, surviving 75s lingered in service with smaller nations and in training roles. Some remained in French Army reserve stocks into the 1960s. Finland, which had purchased 200 guns from the United States in 1940, kept them in service for training until the 1990s. The gun had been in active military service for nearly a century. Today, Canon de 75 Model 1897 field guns are preserved in military museums around the world. The example at the Musée de l'Armée in Paris saw action in World War I before entering the collection in 1920. The gun named Bridget, which fired the first American shot of World War I, sits in the US Army Ordnance Museum. Other examples can be found in Britain, Poland, and dozens of other countries where the gun served. The legacy of the French 75 extends far beyond the weapon itself. It established the template for modern field artillery. Every field gun developed in the 20th century owed a debt to the 75's innovations. The hydropneumatic recoil system became standard. The quick-action breech mechanism was copied worldwide. Fixed ammunition for field guns became universal. Independent sighting systems separate from the gun tube became the norm. The 75 proved that rapid fire was more valuable than large caliber for field artillery. The combination of range, accuracy, and rate of fire that the 75 pioneered became the standard by which all field guns were judged. The gun also demonstrated the value of industrial capacity. France produced over 21,000 French 75s during its service life. More importantly, France produced over 200 million rounds of ammunition. This scale of production showed that modern warfare would be won by industrial might as much as by tactical skill. The French understood early that artillery was fundamentally about logistics. Having a good gun meant nothing without unlimited ammunition. The 75's success rested on France's ability to manufacture shells by the millions. Later conflicts would confirm this lesson. Artillery dominance belonged to nations that could sustain production of both guns and ammunition at industrial scales. The 75 also influenced military doctrine for decades. French military thinking after 1897 elevated artillery to the decisive arm. The gun's success at the Marne and Verdun seemed to confirm that artillery firepower could stop any infantry attack. This led to the artillery-heavy defensive doctrine that dominated French thinking in the interwar period. The Maginot Line was essentially an artillery fortress system. Unfortunately, this doctrine proved disastrous when mobile warfare returned in 1940. The lesson that firepower alone couldn't win wars was learned again at great cost, but perhaps the most significant legacy is technological. The 75 represented a breakthrough in solving the recoil problem that had plagued artillery for centuries. The hydro-pneumatic system worked so well that variations of it are still used in artillery and other recoil-operated systems today. Modern artillery pieces use far more sophisticated recoil systems, but the basic principle remains the same. Hydraulic fluid absorbs recoil energy, compressed gas returns the system to battery, and the gun stays on target between shots. The French engineers who developed this system between 1892 and 1896 created something that would influence weapon design for over a century. The gun even entered popular culture. After World War I, a cocktail was created and named the French 75, supposedly because it packed the same kick as the artillery piece. The cocktail, made with gin, champagne, lemon juice and sugar, became one of the most famous drinks in the world. The name lives on in bars everywhere, long after the gun itself passed into history. In 1985, at a reunion of German and American fighter pilots in Phoenix, former Luftwaffe General Adolf Galland was asked about his experiences. In discussing artillery, he mentioned the French 75. His comment was telling. "We respected that gun from the First War through the Second. It just kept showing up, decade after decade, still dangerous, still effective." March 1898 to 1945. 47 years of active service across 2 world wars. The Canon de 75 Model 1897 began as a closely guarded secret weapon designed to give France artillery superiority. It became the most widely used field gun in history. It established the standard for modern artillery, and it served longer than any field gun before or since. The engineers who designed it could never have imagined that their creation would still be firing in anger half a century later, in conflicts they couldn't have conceived, using it in roles they never intended. The gun designed to fire shrapnel at infantry in 1897 ended its career firing at tanks in 1945. It was mounted in fortifications, on trucks, on trains, on half-tracks, and in tanks. It fought in Europe, Asia, Africa, and the Pacific. It was the last field gun to serve in both world wars from beginning to end. The Canon de 75 Model 1897 survived 2 world wars not because it was perfect, but because it was good enough and available in enormous numbers. It survived because industrial production could manufacture thousands of guns and hundreds of millions of shells. It survived because the basic design was sound enough to be adapted to roles never imagined by its creators. And it survived because even as it became obsolete, it remained effective enough to be worth keeping. The French 75 wasn't the best field gun ever made. Later designs surpassed it in range, shell weight and armour penetration. But measured by longevity, by numbers produced, by global distribution, and by historical impact, no field gun has ever matched it. From the secret workshops of Puteaux Arsenal to the beaches of Normandy, from the mud of Verdun to the jungles of the Pacific, the thunder of the French 75 echoed across half a century of warfare. When it finally fell silent in 1945, an era of warfare ended with it. The age of horse-drawn field artillery, of guns that could be manhandled into position by their crews, of direct-fire weapons engaging visible targets, that age belonged to the 75. Modern artillery would be mechanized, radar-directed, firing at targets over the horizon. But for 50 years the sound of rapid-fire 75mm shells was the sound of artillery itself. The 75, the 75, the French 75, whatever soldiers called it, the name meant the same thing. It meant accurate, sustained, devastating fire. It meant survival at Verdun. It meant the difference between victory and defeat. The gun designed in secret became the most famous artillery piece in the world. The weapon that was meant to give France a decisive advantage became the standard that everyone else copied. From 1897 to 1945, the French 75 defined what field artillery could be. No gun before or since has held that distinction for so long or so completely. The technical specifications that made the 75 revolutionary remained impressive throughout its service life. The barrel, manufactured from high-grade nickel steel, measured 2.72 meters in length, giving it a length-to-caliber ratio of 36:1. This relatively long barrel provided excellent muzzle velocity while maintaining accuracy. The rifling consisted of 24 grooves with a uniform right-hand twist, completing one full rotation every 25 calibers. This spin stabilization gave the 75mm projectile exceptional accuracy at ranges up to 8,500 meters. The breech mechanism deserved particular attention. The Nordenfelt eccentric screw design used an interrupted thread system. The breech block had threads covering only about 60% of its circumference. When the breech operator turned the handle 90 degrees, these threads rotated past corresponding threads in the breech ring. Then the block moved backward to open the chamber. This meant the breech could open and close with just a quarter turn in each direction, compared to the multiple full rotations required by earlier designs. The system was so reliable that malfunctions were extraordinarily rare. American artillerymen training on the 75 in 1917 were astonished by the simplicity and speed of the breech operation. The ammunition itself represented careful engineering. Each complete round weighed approximately 12 pounds. The brass cartridge case held the propellant charge, typically 1.76 pounds of smokeless powder. The projectile was crimped into the case mouth, creating a single unit that could be handled and loaded as one piece. This fixed ammunition concept seems obvious now, but in 1897 it was revolutionary for field guns. Most artillery still use separate loading ammunition, where the projectile and propellant charge were loaded individually. The fixed ammunition of the 75 cut loading time in half and eliminated the possibility of loading errors. The propellant itself was poudre B, a smokeless powder based on nitrocellulose that the French had developed in the 1880s. Unlike the black powder used in earlier artillery, poudre B produced minimal smoke. This meant gun positions weren't immediately revealed by clouds of white smoke after each shot. The tactical advantage was enormous. German artillery observers in World War I complained that French 75 batteries were nearly impossible to locate visually. The guns would open fire, deliver devastating barrages, and remain invisible behind their concealed positions. Counter-battery fire was reduced to guesswork. The projectiles came in several varieties, each designed for specific targets. The standard shrapnel round, the obus à balles, contained 290 lead balls, each weighing 11 grams. A small bursting charge in the base of the shell, triggered by a mechanical time fuse, would detonate at a preset distance. The explosion drove the lead balls forward in a cone-shaped pattern. At the optimal burst height of about 20 feet above ground level, and 50 yards in front of the target, the balls would shower down on an area roughly 30 yards wide and 100 yards deep. Against troops in the open, the effect was devastating. A single shrapnel shell could kill or wound every man in an infantry platoon. The high-explosive shell, the obus explosive, contained 1.6 pounds of melanite explosive. Upon impact, the fuse detonated the main charge, creating a blast radius of about 30 feet. The explosion would kill through blast overpressure and fragmentation. The steel shell casing shattered into hundreds of jagged fragments that could inflict casualties out to 100 yards. These shells were particularly effective against field fortifications, equipment, and massed troops. During World War I, high-explosive shells gradually replaced shrapnel as the primary ammunition type, as fighting moved underground into trenches where air-bursting shrapnel was less effective. The time fuses for shrapnel shells were mechanical marvels. The French used a clockwork mechanism that began running when the gun fired. The acceleration of firing compressed a spring that powered the timer. The fuse could be set for any flight time up to about 20 seconds, corresponding to the gun's maximum range. Fuse setters, specialized tools carried by each gun crew, allowed precise adjustment of the timer before loading. The accuracy of these fuses was remarkable. Experienced crews could consistently burst shrapnel shells within 5 yards of their intended point. This precision transformed shrapnel into one of the most lethal weapons on the battlefield. By World War I, the French had also developed illumination rounds, smoke rounds, and gas shells for the 75. The illumination shells contained a magnesium flare suspended beneath a small parachute. These rounds could light up enemy positions at night, making them visible to infantry or other artillery. Smoke shells created screening clouds to conceal troop movements. Gas shells delivered chemical agents, primarily phosgene and mustard gas, turning the 75 into a weapon of chemical warfare. The versatility of the ammunition load meant that a single 75 could switch roles rapidly, firing shrapnel 1 minute and high explosive the next, then smoke to screen friendly forces. The gun shield, often overlooked, was a critical component. The shield consisted of multiple curved steel plates, each 4 mm thick, arranged to deflect small arms bullets and shrapnel fragments. The shield protected the gun crew from frontal fire while leaving the sides and rear open for crew movement and ammunition handling. Early in World War I, crews quickly learned to pile sandbags around the sides and rear of their positions to provide all-around protection. The shield itself weighed about 265 pounds, adding to the gun's total weight, but considered essential for crew survival. German snipers and machine gunners specifically targeted French artillery crews, making the shield the difference between life and death. The sighting system was perhaps the most sophisticated element of the entire weapon. The French École d'application de l'artillerie at Fontainebleau had studied gunnery science extensively in the 1880s and 1890s. Their research led to the independent sight mounting that characterized the 75. The sight was attached to the gun carriage, not the barrel. This meant as the barrel recoiled and returned, the sight remained perfectly aligned on the target. The gunner, seated on a small seat attached to the trail, could keep his eye to the sight continuously, making minute adjustments between rounds without re-aiming the entire weapon. The sight itself incorporated a collimator telescope and range scales. The gunner could see the target through the optics while simultaneously viewing range marks etched on glass reticles. By matching the target image to the appropriate range mark, the gunner could achieve remarkable first-round accuracy. The system worked for both direct fire, where the target was visible, and indirect fire, where the gunner aimed at a reference point and elevation was calculated from firing tables. This flexibility made the 75 effective in diverse tactical situations. The gun crew organisation reflected the weapon's capabilities. The standard crew consisted of 6 men, though some sources list 7 or 8 depending on whether ammunition handlers were counted as crew or support personnel. The chief of the piece commanded the crew and gave fire orders. The gunner operated the sight and fired the weapon by pulling a lanyard attached to the firing mechanism. The loader opened the breech, loaded rounds and closed the breech. The fuse setter adjusted time fuses on shrapnel rounds before they were loaded. 2 ammunition handlers brought rounds from the limber, which was positioned behind the gun. The 6th crew member operated the traverse wheel, which adjusted the gun's horizontal alignment. This crew organisation allowed the 75 to maintain its incredible rate of fire. The cycle worked like clockwork. The gunner aimed and fired. The instant the gun fired, the loader opened the breech. The spent cartridge case was automatically ejected by a spring-loaded extractor. Before the barrel finished its recoil cycle and returned to battery, the loader had a fresh round ready. He loaded it into the chamber and closed the breech. The gunner made any necessary adjustments to the sight. The entire sequence took about 2 seconds. With experienced crews, it could be done in less. Sustained fire of 15 rounds per minute was routine. Bursts of 30 rounds per minute were possible for brief periods. The logistical requirements to sustain this rate of fire were staggering. Each gun was accompanied by its limber, a 2-wheeled cart that carried additional ammunition. The standard limber held 72 rounds, enough for about 5 minutes of sustained fire. Behind the battery position, a caisson, another 2-wheeled cart, carried an additional 144 rounds. This meant each gun had immediate access to 216 rounds before resupply was needed. During major battles, ammunition consumption often exceeded 1,000 rounds per gun per day. Maintaining supply chains capable of delivering this volume of ammunition to hundreds of batteries became one of the great logistical challenges of World War I. The French artillery supply system evolved to meet this challenge. Railway lines were extended as close to the front as possible. From railheads, ammunition moved by truck to forward dumps, then by horse-drawn wagon to battery positions. During the Battle of Verdun, the single road into the fortress, the Voie Sacrée, carried 3,000 trucks per day at its peak. A truck passed every 14 seconds, 24 hours a day. Much of that traffic was ammunition for the 75s defending Verdun. The French proved they could sustain an artillery battle on a scale previously unimaginable. The training required to master the 75 was extensive. French artillery schools conducted courses lasting several months. Gun crews learned not just how to operate the weapon, but how to maintain it under field conditions. The hydro-pneumatic recoil system, while reliable, required regular maintenance. Hydraulic fluid levels had to be checked, Seals had to be inspected for wear. The gas pressure in the recuperator cylinder had to be maintained within specified limits. Too little pressure and the barrel wouldn't return to battery completely. Too much pressure and excessive stress could damage components. Maintenance crews accompanied each battery, performing routine servicing and emergency repairs. American artillerymen arriving in France in 1917 received crash courses in operating the 75. The French established schools near Valdehon and other locations where American officers and NCOs learned French artillery methods. The language barrier complicated training. Many French instructors spoke no English. Many American students spoke no French. Technical terminology had to be learned in both languages. Despite these challenges, American artillerymen became proficient with the 75 relatively quickly. The weapon's design was intuitive. Its operation, once demonstrated, was straightforward. Within weeks, American gun crews were firing effectively, if not yet with the speed and precision of veteran French crews. One aspect of 75 employment that evolved during World War I was indirect fire technique. Early in the war, artillery typically fired over open sights at visible targets, but as trenches deepened and fortifications improved, targets became invisible from gun positions. Artillery had to fire at targets they couldn't see, relying on forward observers to spot impacts and call corrections. The French developed sophisticated systems for indirect fire. Forward observers, equipped with telephones connected by wire to gun positions, would identify targets and calculate their coordinates. Fire direction centers would compute the necessary elevation and deflection to hit those coordinates. Guns would fire based on these calculations, and observers would watch where shells landed, calling for adjustments until shells hit the target. This system required firing tables, books of data showing exactly what elevation and powder charge were needed to reach any range. The tables were calculated using ballistic mathematics and verified by extensive test firing. Every gun crew carried firing tables, and every fire direction center kept master copies. Corrections for weather conditions, including wind, temperature, and barometric pressure, were applied to improve accuracy. By 1918, French and American artillery using the 75 could hit targets they couldn't see with remarkable precision, often achieving first-round hits at ranges exceeding 7,000 meters. The sound of the 75 in action became one of the defining auditory experiences of World War I. The report of a 75 firing was sharp and distinctive, a crack rather than a boom. When batteries fired in volleys, the sound was like thunder, but thunder with a staccato rhythm. Soldiers who experienced sustained 75 barrages described the sound as overwhelming, a continuous crashing that made conversation impossible and left ears ringing for hours afterward. German soldiers developed the ability to distinguish French 75 fire from German artillery by sound alone. The rapid fire capability gave the 75 a characteristic staccato quality that German guns, firing more slowly, couldn't match. The psychological impact of artillery fire, particularly rapid fire from weapons like the 75, was studied extensively after World War I. Medical officers documented a condition they called shell shock, now recognized as combat-related post-traumatic stress disorder. Sustained artillery bombardment broke men mentally as surely as shrapnel broke their bodies. The constant threat of sudden death from an unseen weapon, the helplessness of cowering in a dugout while shells rained down, the violent deaths of comrades torn apart by explosions, all of this produced psychological casualties on a massive scale. The 75, with its rapid fire and large ammunition capacity, contributed significantly to the artillery-induced trauma that characterized the Western Front. The tactical employment of 75s evolved throughout World War I. Early in the war, batteries were positioned relatively close to the front, sometimes within 2,000 meters of enemy lines. This allowed for direct fire support and rapid response to infantry requests. But German counter-battery fire made forward positions dangerous. As the war progressed, batteries moved farther back, relying on indirect fire and forward observers. By 1918, many 75 batteries operated from positions 5,000 to 7,000 meters behind the front lines, near the maximum range of the weapon. This reduced losses to counter-battery fire but made fire support more complex and time-consuming. The development of creeping barrages represented a major tactical innovation. In this technique, artillery would fire in a line just ahead of advancing infantry. At timed intervals, The artillery would lengthen their range and the shell impacts would creep forward. Infantry would follow closely behind the barrage, arriving at enemy positions while defenders were still pinned down by artillery fire. The 75 was ideal for creeping barrages. Its rapid fire created a dense curtain of explosions. Its relatively light shell, while less destructive than heavy artillery, was less likely to create craters that would impede the advancing infantry. French and American offensives in 1918 relied heavily on creeping barrages delivered by 75s. The Battle of the Somme in 1916 demonstrated both the power and limitations of artillery preparation. Before the British infantry attack on July 1st, Allied artillery, including French 75s on the southern sector, fired a week-long preparatory bombardment. Over 1.5 million shells were fired at German positions. The intention was to destroy German defences and kill defenders, allowing infantry to walk across no man's land and occupy the ruins. But German dugouts, buried 30 feet underground, survived the bombardment. When the barrage lifted and infantry advanced, German machine gunners emerged and inflicted 57,000 British casualties on the first day, the bloodiest day in British military history. The 75, for all its capabilities, couldn't penetrate deep dugouts. This limitation applied to all field artillery and led to increased reliance on heavy howitzers firing larger, more powerful shells. The Battle of Cambrai in November 1917 showed a different approach. Here, British forces attacked without a preliminary bombardment, using tanks to break through German lines, while artillery fired surprise barrages on German gun positions and command posts. The attack achieved complete tactical surprise and made significant gains before German reserves counterattacked. The lesson was clear: artillery preparation alerted defenders. Surprise bombardments followed immediately by infantry assault were more effective. The 75's rapid rate of fire made it ideal for sudden, overwhelming barrages that gave defenders no time to react. By 1918, Allied artillery doctrine had evolved significantly. Counter-battery fire using observation aircraft and sound-ranging equipment to locate enemy guns, then destroying them with artillery fire, became a priority. The 75 participated in counter-battery missions, though heavier guns were preferred for this role due to their greater range and shell power. The 75 focused increasingly on suppression and direct support. When infantry requested fire support, 75 batteries could respond within minutes, plastering enemy positions with rapid fire that forced defenders to take cover and stopped reinforcements from moving. The final Allied offensives of 1918 showcased the 75 at its peak effectiveness. The 100 Days Offensive, beginning in August 1918, saw coordinated attacks all along the Western Front. French, British and American forces advanced, supported by massive artillery preparations and rolling barrages. American forces particularly distinguished themselves in the Meuse-Argonne Offensive, the largest American battle of the war. Here, over 2,000 artillery pieces, predominantly 75s, supported the attack. On the first day, September 26th, American artillery fired over 1 million rounds. The sustained fire suppressed German defences and allowed American infantry to advance several miles. German accounts of facing American artillery in 1918 emphasized the sheer volume of fire. German officers noted that American artillery seemed to have unlimited ammunition. Batteries would fire continuously for hours, something German guns, constrained by ammunition shortages, couldn't match. One German regimental history described an American barrage as a storm of steel that made movement impossible and survival unlikely. The combination of American industrial capacity producing ammunition and French 75s firing it created artillery dominance that German forces couldn't counter. The armistice on November 11, 1918 found thousands of French 75s deployed along the Western Front. Many of these guns had been in continuous service since 1914. They had fired hundreds of thousands of rounds. Barrels were worn, requiring relining or replacement. Recoil systems had been serviced countless times. Carriages showed the wear of 4 years of constant use. Yet the guns were still functional, still capable of delivering effective fire. The robust design that allowed the 75 to survive years of combat would serve it well in the decades to come. The interwar period saw the 75 distributed worldwide. American forces brought hundreds of 75s home and placed them in storage. Throughout the 1920s and 1930s, these guns equipped National Guard artillery units and remained in active service with regular army units. The lack of funding for new artillery meant the 75 remained America's primary field gun. When the US Army conducted maneuvers and training exercises, they did so with 75s that had fought in France decades earlier. Poland's experience with the 75 proved particularly significant. The newly independent Polish state recreating its military after over a century of partition needed artillery. France, America's wartime ally, provided substantial numbers of 75s. By 1920, during the Polish-Soviet War, Polish artillery batteries equipped with 75s fought against Red Army forces advancing on Warsaw. The Battle of Warsaw in August 1920, the miracle on the Vistula, saw Polish forces halt and reverse the Soviet advance. Polish artillery, firing French 75s, played a crucial role in the victory. The guns proved as effective against Bolshevik cavalry and infantry as they had been against Germans in World War I. Throughout the 1920s, Poland continued acquiring 75s and established domestic production facilities to manufacture ammunition. By 1939, Poland possessed one of the largest stocks of 75mm artillery outside France. These guns were organised into divisional artillery regiments, typically with 3 battalions per regiment, each battalion equipped with 4 batteries of 4 guns. On paper, this gave Poland substantial artillery strength. In practice, the guns were obsolescent, lacking the range and mobility of more modern designs. But they were available, they were familiar, and Polish gunners were well trained in their employment. The Spanish Civil War from 1936 to 1939 provided another testing ground for the 75. Both Republican and Nationalist forces used the gun. Republican forces received 75s from France and the Soviet Union, while Nationalist forces captured stocks from Republican arsenals. The gun performed adequately in the relatively low-intensity conflict, though the war also previewed tactics that would dominate World War II. German and Italian forces supporting the Nationalists deployed more modern artillery and demonstrated combined arms tactics involving armour and aircraft that rendered traditional artillery employment increasingly obsolete. September 1939. Germany invaded Poland and World War II began. Polish artillery fought desperately against overwhelming German forces. The 374 French 75s in Polish service formed the backbone of divisional artillery. They fired against advancing German infantry and armour, inflicted casualties, and delayed the German advance. But Polish forces were outmatched. German combined arms tactics, integrating panzer divisions with close air support from the Luftwaffe, overwhelmed static Polish defences. Polish artillery, including the 75s, fought effectively when they could, but German forces simply bypassed strongpoints and drove deep into Polish rear areas, cutting supply lines and surrounding defenders. The performance of Polish 75s against German armour was mixed. The guns were not designed as anti-tank weapons. Their relatively low-velocity shells lacked the kinetic energy to penetrate heavy armour. Against light tanks like the Panzer and Panzer II, direct hits could disable or destroy the vehicle. Against Panzer III and Panzer IV tanks with thicker armour, the 75s struggled. Polish gunners learned to aim at tracks, vision slits, and other vulnerable points. Some succeeded in disabling German tanks, but the guns were fundamentally ill-suited for the anti-tank role. By early October 1939, Poland had fallen. Hundreds of Polish 75s were captured intact and entered German service. May 1940. The Battle of France began with German forces invading Belgium, the Netherlands, Luxembourg, and France. The French army deployed approximately 4,500 Canon A75 Model 1897 guns, now designated the 75 Model 1897-33, in their modernised form with pneumatic tyres and improved carriages. These guns equipped divisional artillery regiments throughout the French army. On paper, French artillery strength appeared formidable. In practice, French doctrine and deployment proved disastrous. French military thinking in 1940 remained rooted in World War I experience. The High Command expected a relatively static campaign. Artillery would be positioned to support defensive lines. Infantry would hold positions while artillery pounded attacking forces. This approach had worked at Verdun in 1916. It failed catastrophically against German mobile warfare in 1940. German panzer divisions punched through weak points in Allied lines and exploited breakthroughs with lightning speed. French artillery found itself outflanked and surrounded before it could effectively engage. Batteries that might have stopped German infantry with massed fire had no time to set up, calculate firing data, and engage before German tanks appeared in their rear areas. The 75s that did get into action performed as designed. They fired effectively against German infantry and light vehicles, but the tactical situation rarely allowed sustained fire missions. German forces moved too quickly. Air superiority belonged to the Luftwaffe, which attacked French gun positions mercilessly. Stuka dive bombers specifically targeted artillery batteries, and without air cover, French guns were vulnerable. Many 75 batteries were destroyed by air attack before firing a shot. Others were overrun by advancing German armour. Some fought desperate last-ditch actions, firing over open sights at point-blank range against approaching tanks, destroying a few vehicles before being overwhelmed. Within 6 weeks, France had fallen. The speed of the defeat shocked the world. On June 22, 1940, France signed an armistice. German forces captured enormous stocks of French equipment, including thousands of 75mm field guns. Combined with Polish guns captured in 1939, Germany now possessed one of the world's largest inventories of 75mm artillery. These weapons represented a logistical windfall for a nation fighting an expanding war on multiple fronts. The Germans were pragmatic about captured equipment. If it worked, and they had ammunition for it, they would use it. The French 75 became the 7.5cm Feldkanone 97 Schaft in German service. Initially, these guns equipped second-line units, occupation forces, and coastal defence positions. They weren't considered frontline weapons, but they were available in large numbers and they were serviceable. German units stationed in occupied France, Norway, Denmark, and the Low Countries received 75s for local defence. The guns were adequate for this role, and using captured weapons freed German-made artillery for frontline service. Then came Barbarossa. On June 22, 1941, Germany invaded the Soviet Union with the largest military operation in history. Initial victories were spectacular. German forces advanced hundreds of miles, destroying entire Soviet armies and capturing millions of prisoners. But Soviet resistance stiffened, and German forces encountered the T-34 medium tank. This tank shocked German commanders. Its sloped armour deflected German anti-tank rounds. Its 76mm gun outranged German tank guns. Its wide tracks gave it excellent mobility in mud and snow. The T-34 was superior to every German tank in service in 1941. German anti-tank units desperately needed weapons that could stop T-34s. Existing anti-tank guns, the 37mm PaK-36 and 50mm PaK-38, were inadequate. The PaK-36's shells literally bounced off T-34 armour, earning it the nickname door knocker from German troops. The PaK-38 was better, but still struggled against frontal armour at normal combat ranges. German forces needed larger calibre, anti-tank guns immediately. Development and production of new weapons would take time Germany didn't have. The solution was to convert existing weapons to anti-tank use. German engineers examined captured French 75s. The gun had decent bore diameter and reasonable muzzle velocity. Could it be converted into an effective anti-tank weapon? The answer was yes, with modifications. German workshops began converting French 75 barrels and mounting them on German PaK-38 carriages. The PaK-38 carriage was lower, giving a better silhouette for concealment, and had better traverse and elevation mechanisms. A muzzle brake was added to the French barrel to reduce recoil forces, necessary because the lighter PaK-38 carriage couldn't absorb the full recoil of the 75mm gun. The resulting weapon was designated 7.5cm Panzerjägerkanone 97-38, or PaK 97-38. German ammunition factories produced armour-piercing shells for the 75mm bore. The standard round was a capped armour-piercing shell with a ballistic cap to improve aerodynamics and a hardened cap to prevent shattering on impact. At 500 metres range, this round could penetrate about 70mm of armour at 30 degrees angle. This was sufficient to penetrate the hull sides and turret sides of T-34 tanks. Frontal armour, 45mm thick but heavily sloped, was more problematic. Penetration was possible, but not reliable. Over 3,500 PET 97-38 conversions were completed between 1942 and 1943. These guns equipped German anti-tank units on the Eastern Front throughout 1942 and into 1943. They weren't ideal. The relatively low velocity meant penetration performance was marginal against later Soviet tanks like the KV-1 heavy tank or up-armoured T-34 variants. But the guns were available. They could kill T-34s under favourable conditions, and they filled a desperate need. German anti-tank gunners learned to wait for side shots, or to engage at ranges under 500 metres, where penetration was more reliable. Soviet tankers learned to respect these converted French guns. A T-34 commander who survived the war recalled an engagement in 1942 near Kharkov. His tank was hit by a German anti-tank gun from the flank at close range. The shell penetrated behind the turret ring, killing the loader and wounding the gunner. The tank caught fire and the crew bailed out. He later learned from German prisoners that the gun that hit him was a captured French weapon from World War I. The irony wasn't lost on him. A gun designed to fire shrapnel at French infantry in 1897 had nearly killed him in a Soviet tank in 1942. The P-97-38 remained in German service through 1943. As better anti-tank guns became available, the conversions were gradually withdrawn from frontline service, but they had served their purpose. During the critical period when German forces faced the T-34 with inadequate anti-tank weapons, the P-97-38 provided a stopgap solution. Thousands of German anti-tank gunners went into battle with weapons built around French artillery barrels manufactured decades earlier. Some of those gunners survived because the guns worked well enough to kill Soviet tanks. Meanwhile, thousands of other captured 75s found employment in the Atlantic Wall. After the failure to invade Britain in 1940, Germany began fortifying the Atlantic coastline against Allied invasion. Hitler's Atlantic Wall eventually stretched from Norway to Spain, consisting of thousands of fortified positions. Many of these positions needed artillery. The guns had to be protected from Allied naval bombardment and air attack, which meant concrete casemates and bunkers. They needed to cover beaches and approaches where Allied troops might land. Range wasn't critical. Most engagement ranges would be under 5,000 metres. The French 75, with its rapid fire capability and availability in large numbers, was ideal for this role. German engineers designed standard casemate positions for the 75. The guns were mounted on pedestal mounts inside concrete bunkers, with embrasures providing a limited field of fire. The thick concrete walls protected the gun and crew from everything except direct hits by heavy naval shells or bombs. Ammunition storage was built into the bunker. Crew shelters protected gunners between engagements. These fortifications turned the 75 into a fixed coastal defence weapon. Hundreds of such positions were constructed along the Atlantic coast. When Allied forces landed in Normandy on June 6, 1944, they faced some of these bunkers. At Omaha Beach, several fortified positions armed with French 75s engaged landing craft and troops on the beach. The rapid fire from these guns inflicted casualties and destroyed vehicles. Allied forces had to systematically reduce these positions using direct fire from destroyers, tank fire, and infantry assault with explosives. The 75s fought until overrun, or until their crews were killed or captured. Some bunkers held out for hours, continuing to fire even as Allied forces pushed inland. One particular bunker at Pointe du Hoc was equipped with captured French 75s, though the guns had been moved inland before the landing. US Army Rangers scaled the cliffs at Pointe du Hoc under fire, believing they were attacking heavy gun positions that threatened the invasion beaches. When they reached the top, they found the positions empty. The guns, including 75s, were later found camouflaged a mile inland and destroyed by the Rangers. This position exemplified German use of the 75s in coastal defence. The guns were available, they were adequate for the role, and they freed more modern German weapons for other purposes. The story of the French 75 in World War II wasn't limited to German use of captured guns. Allied forces also employed the weapon. Britain, as mentioned, received almost 900 guns from the United States in 1940 and used them until 1945. British units deployed 75s in anti-tank roles, field artillery roles, and coastal defence. The guns served in Britain itself, in North Africa, and in other theatres. While British forces preferred their own 25-pounder gun howitzer for field artillery, The 75s filled gaps and provided additional firepower when needed. American use of the 75 in World War II was more extensive than often recognized. While the US Army developed and fielded the 105mm M2A1 howitzer as its primary divisional artillery piece, tens of thousands of French 75s remained in American inventory. These guns found various uses throughout the war. In 1941, facing the need for mobile tank destroyers to counter German armor, American engineers mounted 75mm guns on M3 half-track chassis, creating the M3 gun motor carriage. This improvised vehicle served until dedicated tank destroyer designs like the M10 became available. The 75 also armed the M3 Lee medium tank. The M3 was an interim design produced while the M4 Sherman was being developed. It featured a 75mm gun in a sponson mount on the right side of the hull and a 37mm gun in a rotating turret. The 75mm gun provided the main firepower. These tanks saw action in North Africa in 1942 and in the Pacific Theatre throughout the war. Against Japanese tanks, which were generally lightly armoured, the 75mm gun was more than adequate. The M3 Lee served effectively until replaced by the M4 Sherman. In the Pacific, American forces also used towed 75mm guns. Some were vintage World War I weapons pulled from storage. Others were more modern M18 977A4 versions with updated carriages. These guns supported amphibious assaults and ground operations across the Pacific Islands. Japanese fortifications, often built into caves and bunkers, required direct fire from artillery and tanks. The 75, firing high explosive shells at point-blank range, proved effective at reducing these positions. Its rapid fire allowed sustained bombardment that suppressed Japanese defenders and destroyed fortifications. The Philippines campaign in 1944 and 1945 saw extensive use of American 75s. Artillery units supported the reconquest of the islands, firing in support of infantry operations against determined Japanese resistance. The Japanese themselves had acquired some French 75s before the war and used them in defensive positions throughout their occupied territories. This meant that in some engagements, both sides were using variants of the same weapon, a gun designed nearly 50 years earlier. Free French forces, fighting alongside the Allies after France's liberation, also employed 75s. French units in North Africa, Italy, and later in France itself used whatever artillery was available. Some French units received modern American equipment. Others made do with older French weapons, including 75s that had been hidden from German occupation forces or recaptured from German units. French artillery at the liberation of Paris in August 1944 included some 75mm guns, though by then they were clearly obsolescent. By 1945, the Canon de 75 Model 1897 was thoroughly obsolete as a frontline weapon. Newer designs had longer range, fired heavier shells, and offered better armour penetration in anti-tank roles. But the gun continued serving because it was available and it worked. Finnish forces, who had purchased 200 guns from the United States in 1940, used them throughout the continuation war against the Soviet Union from 1941 to 1944. Finnish gunners appreciated the weapon's reliability and rapid fire, even if its range limited effectiveness against Soviet artillery firing from greater distances. When World War II ended in 1945, the French 75 finally began its retirement from frontline service. Major powers scrapped most of their stocks or relegated guns to training and reserve roles. But smaller nations continued using the weapon for decades. The French military kept 75s in reserve stocks through the 1950s. Some saw action in French colonial wars in Indochina and Algeria, though by then they were supplementary weapons rather than primary artillery. The last combat use by French forces probably occurred in the 1950s, bringing the gun's combat service to nearly 60 years. The United States maintained stocks of 75s through the 1950s for training purposes. Many were eventually given to friendly nations as military assistance or sold as surplus. Some ended up in museums, others were cut up for scrap. But the gun's influence persisted. The basic design principles it established, particularly the hydro-pneumatic recoil system and quick-acting breech mechanism, remained standard in artillery design. Every modern artillery piece owes something to the French 75. The gun's place in military history is secure. It was the first truly modern field gun, establishing standards that defined artillery for half a century. It served in more conflicts, in more countries than perhaps any other artillery piece in history. From the trenches of Verdun to the beaches of Normandy, from the plains of Poland to the jungles of the Pacific, the French 75 fought in every major theatre of both world wars.